Record. While we're waiting for it to start recording, make sure you get your notes out. There we go. Okay, so make sure we've got our notes out and ready to go. Today we are learning about the Pythagorean Theorem, which is something that you can use with right triangles to find missing sides. Let's see. Anyone heard of the Pythagorean Theorem before? Like maybe in some previous math class, 8th grade or 9th grade? Anyone think they've heard of that? Caleb has. Awesome. So those of you who have heard of it already or maybe used it a little bit beforehand, you're going to have a leg up on the rest of us today, because that is what we're doing today, Pythagorean Theorem. That is exactly it, Caleb. A squared plus B squared equals C squared. So we're going to go over today what it is, how we use it, and we'll also go over a little bit of a way that you can show it or derive it just for fun. Because that sort of thing's fun, right? Okay. So, notes. Oh, come on. I hate it when it does that. There it is. All right, hopefully that is somewhat focused. All right, 9.1. Pythagorean theorem. Okay, so a lot of us probably know this as a squared plus b squared equals c squared, but we kind of want to unpack what that means and things like that. So the first thing that we're going to do is write down what the theorem says. Or what the, I guess we'll write down what the formula is, and then we'll talk about kind of what it works for. So for a right triangle, because this only works for right triangles, we have this formula, a squared plus b squared equals c squared. And so if we're thinking about kind of the anatomy of a right triangle, or a triangle in general, remember we talked about like the base angles theorem and stuff like that. And we talked about legs and we talked about the base and that sort of thing. So for a right triangle, if this is just any generic right triangle, the two sides that are the shorter two sides are called the legs. So this is one leg, and this is the other leg. And then there's a special name for the longest side. Does anyone know what the name for that longer side is? Yeah, Caleb's got it. It's the hypotenuse. And in case it's kind of hard to tell, sometimes it is hard to tell which side is the longest and which sides are shorter. It's the one that's across from the right angle. So if the right angle is not touching that side, if it's across from that right angle, that is the hypotenuse. And so when we talk about this theorem for a right triangle, A is the length of one of the legs. B is the length of the other leg. And C is the length of the hypotenuse. So what we're doing here when we talk about the Pythagorean theorem for a right triangle It's the leg squared plus the leg squared equals the hypotenuse squared. So a lot of times people like to go, okay, A is the shorter leg, B is the longer leg, and C is the hypotenuse. You can do that if you want, but really it doesn't matter which one is A and which one is B. As long as we're consistent and as long as A and B are both legs and C represents the hypotenuse. This is the one that we have to get correct. This is the one that is special. Okay. Any questions up to this point? Okay. And if you do have any questions at any point, feel free to type in the chat or unmute yourself and say so. Do I have that one? No, my ruler seems to have walked away from me. Oh, well. We can still do this a little bit more theoretically. We're going to do a geometric representation of what this theorem is really. It's kind of a geometric proof of this theorem if we were to actually have like, if I were to have a ruler, it would be a little bit more of a convincing proof. But anyway, let's say we've got, need a little bit more room than that. We'll do it down here. Okay, so I've got a right triangle drawn. We're going to call this a geometric representation. Okay. So I've got a right triangle here. And we're going to say that this side length is 3, this side length is 4, and this side length is 5. So a representation of what's going on, it can be easily represented by areas of squares. Because if you think about it, when we take something and square it, like the leg length squared, that's really the area of a square with the side length being that length of the leg. So let's for a moment make a square on each side here. And we're going to do our best with this because, like I said, I don't know where my ruler went. Okay. So if I'm making squares here, this square is a 3 by 3 square. This one is a 4 by 4, and this one is a 5 by 5. So if I were to make grid marks within each square, like let's say, like this, so we have 4 units by 4 units there as well. So that's a 4 by 4 square. This one will be a 3 by 3. And this one will be 5 by 5. Okay. So inside of here, 3 by 3 means that there are 1, 2, 3, 4, 5, 6, 7, 8, 9 squares. And then on a 4 by 4, inside of here, there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 squares. Okay. So there's 3 squares, or 3 by 3, which is 9 squares in here, 4 by 4, which is 16 squares in here. In here, there should be 25 squares, right? Because it's a 5 by 5. So kind of a representation of what the Pythagorean theorem says. It says that this leg squared, so 3 squared, so 9 of these, plus 4 squared, so 16 of these, should fit inside of here, inside the 5 squared. So let's see how that works out. I'm going to start with the 4 by 4, make sure all those fit. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right, so now we fit all of the orange ones from the 4 by 4 inside here. Now I want to add to it the 9 squares from the 3 by 3. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9. And goodness, they all fit. So this is another way that we can kind of represent what's going on here. All the squares that make up this one plus all the squares that make up this one equals all the squares that are made up by this one. And this works for any right triangle, that the leg squared plus the leg squared equals the hypotenuse squared. Okay, so that's kind of a geometric representation of what's going on. Now we're going to actually figure out how we would use this to solve for a missing side. So I'm going to kind of put this off to the side, and we're going to do an example. So sometimes you'll be given a picture of a triangle and asked to solve for the missing side. Sometimes you'll just be given side lengths and asked to solve for a missing side. So for this first example, we're going to be given that A is 5, B is 12, and we don't know what C is. We want to solve for C. Okay. So if you are straight up given the side lengths like this, all we would need to do is we've got A squared plus B squared equals C squared. I'm going to plug in numbers for A and B and use it to find C. So we know A is 5, we know B is 12, so we have 5 squared plus 12 squared equals C squared. And then we just want to simplify this and solve using order of operations. So I'm going to do the exponents here. 5 squared is 25. 12 squared is 144. Be careful. The thing I see a lot of people mess up on here is the concept of what something squared is. Remember, when you square something, you're not just multiplying by 2, you're multiplying it by itself. So 5 squared is 5 times 5. 12 squared is 12 times 12. A million squared is a million times a million. Not just times 2. So that's something to be careful of here. That's a potential hang up. And then it's equal to C squared. Then we want to add those two things together. 144 and 25 together is 169. And that's equal to C squared. And then we're almost done, but not quite. 169 is not our answer. What do I have to do to get rid of a square? Anyone know? Square root, exactly. So if I take the square root on both sides, the square root cancels out the square. And then I would type the square root of 169 into the calculator if I didn't know what that was already. So the square root of 169 happens to be 13. So C equals 13 would be our answer. That's our missing side. That's our missing hypotenuse. All right. Any questions off of that? Okay. So yeah, just to kind of recap what we did, we took our two legs, A and B, and plugged them in for A and B right here. So we got 5 squared plus 12 squared equals C squared. We squared the 5 to get 25, squared the 12 to get 144, equals C squared. Then we square root both sides once we add these two things together, and we get 13 here. So that's one type of situation that we might see, where we're given both of the legs and we need to find the hypotenuse. Another case that we might see will be our next example. We might see a triangle. And we might be told that this side length is 8 and this one is 10. And we need to find the missing side. All right. So looking at this one, what I would do first is label my sides as A, B, and C. So, and the most important one is C, making sure that you get C correct. So between 8, X, and 10, which one's going to be C? Which one's going to be the hypotenuse? Yeah, Ashton, 10. Because it's across from the right angle, it's the longest side. That one's going to be C. And then between these other two, it does not really matter which one is A and which one is B. So I'll call this one A and this one B. So then, with A squared plus B squared equals C squared, I'm going to replace each of these values with ones from my triangle. So X squared plus 8 squared equals 10 squared. And then we're going to solve this just like we would anything algebraic, just like we did up here. So we start by squaring the things that can be squared. So 8 squared is 64, 10 squared is 100. Then we want to get x by itself, so we subtract 64 from both sides. We get that x squared is 36, since 100 minus 64 is 36. And then lastly, just like we did up here, we're not done yet. We have to square root both sides to get x is 6. And that's really all there is to it. Any questions with this one? Any numbers we're not sure where they came from? Any steps we're not sure how or why they happen? Okay, then I'm going to give you guys a couple to try, and then we will do one more thing, and then we'll be done with the lesson for today. So you try. First one, you're told that A is 15, B is 36, and we want to know what C is. And for the second one, it'll be, let me find another good one. Oh, we'll just do a random one. 5, 7, or no, 5. We'll call this one 12, and this is what we're missing. Okay, so go ahead and try both of those. When you think you've got them, type "got it" in the chat, and then we will go over it. You will want a calculator for these, typically. Also, it's good to note that sometimes you don't get whole number answers. So for one of these, that will be the case. You don't get a whole number answer. All right, Caleb's got it. For both of these, we should be starting out with a squared plus b squared equals c squared. Ashton's got it. Awesome. Give you another minute or two. Paula's got it. Kaylee's got it. Nice, Jade. Okay. So for this first one, we're plugging in 15 and 36 for A and B. And 15 squared and 36 squared are probably not things that you know off the top of your head. Maybe the 15, because that one's 225 and 15 is a multiple of 5. So those tend to be a little bit easier to square in your head or to memorize if you wanted to do so. But definitely not 36 squared. I mean, unless you want to have that floating around your brain. 36 squared is 1,296. So adding these two together, you get 1,521 equals c squared. And then it's just a matter of taking the square root on both sides. And you should get 39 for C. So if you got 39, you are correct. So that first one, we got a whole number answer. The second one, you're not going to get a whole number answer. At least I don't think so. Okay. So for the second one, what number did we pick to be C? Which number is C? 12. Yep, thanks, Jade. 12 is C. And then these two, it does not matter which one is A and which one is B. I'll go ahead and make this one A and this one B. So we get x squared plus 5 squared equals 12 squared. And then simplifying from here, x squared plus 25 equals 144. Minus 25 on both sides. We get x squared equals 119. And then at this point, this is where there's kind of two different ways that you can write your answer. So I know this is not our answer. We're not quite done yet. We have to square root both sides. But There are two different possibilities here. If you are asked for something in exact form, you would write the square root of 119. That would be your exact form answer. If you are asked to round, then you would stick square root of 119 into your calculator, and you would get about 10.9, depending on what you're asked to round to. So like on your homework tonight in IXL, they're going to ask you to round to the nearest tenth. So they'll ask you to round to 1 decimal place. But sometimes different IXL sections or like Big Ideas sometimes will ask you to leave it in exact form. This is considered exact form here. So if you take the square root and you get like a long decimal or something like that, that's typically a case where exact form would be this. If you get like something that terminates, like if you get just a number like 39, this is considered exact form for this problem, because the square root of 1,521 comes out to one integer, not a decimal. But over here, if it comes out to a decimal, then the exact, or a decimal that doesn't like stop or repeat, then this would be considered the exact form. So anyway, the typical way that you'll be asked to write it is in a decimal format, but occasionally you could run into a case where you're asked to leave it exact, just like that. Okay, any questions so far? Any numbers we don't know where they came from? Any steps or problems that we want to go back to? Okay. Then the second thing that we have to talk about today is, so we talked about the Pythagorean theorem. Now we want to talk about the converse of the Pythagorean theorem. So the Pythagorean theorem says that if we have a right triangle, then this equation works out. The converse says if this equation works out, then you know you're working with the right triangle. So we can use the converse of the Pythagorean theorem to determine if we are working with a right triangle. So that's kind of nice. So that's what we're going to work with next. Converse of the Pythagorean theorem, which says if a squared plus b squared equals c squared, then the triangle is a right triangle. So if that equation works out, then we know we're working with a right triangle, and we can use this again to determine if something is a right triangle or not. So the way that you'll see this played out is, let's see, we're on example number 3 now. A triangle has side lengths um, 10, 14, and 7. Is it a right triangle? Okay. So what we want to do then is use this equation, plug in these numbers, and check. If the equation works out and it makes a true statement, then we would say, yes, it's a right triangle. If it doesn't work out and makes a false statement, we would say, no, it's not a right triangle. So the first thing we need to do is figure out which side length is going to be A, B, and C. So looking at these 3 numbers, Which one do you think we should put in for C? Any ideas? All right, so we got to vote for 7. Anyone think 10 or 14? We got to vote for 14. Anyone else have an idea or an opinion here? All right, Jade, why did you pick 14? Or Alex or someone who picked 14? Why did we pick 14? We know C is the hypotenuse, right? And what do we know about the hypotenuse? It's the biggest, yeah. So if any of these has a shot at working out as C, it would have to be your biggest side. So the biggest one is going to be C, and then it doesn't really matter which of the other two are A or B. So I'm just going to say 10 is A and 7 is B. The one that really matters is that the biggest is C. So we're going to check and see if 10 squared plus 7 squared is 14 squared. If this makes a true statement, then it's a right triangle. If it makes a false statement, then it's not a right triangle. So here we go. 10 squared is 100. 7 squared is not 42, 49. And 14 squared is 196. So when we come down to it, 100 plus 49 is 149. 149 equals 196. That is not true. So this would be not a right triangle. If this made a true statement, if we got down to 149 equals 149, then we would say, yeah, that's a right triangle. But since we got down to something that is false, we say it's not a right triangle. Let's try another. This time our triangle side lengths are going to be 10, 26, and 24. All right, so this time, what one's going to be C? Yep, exactly. 26. And then again, on the other two, it does not really matter which one is A and which one is B. So that's what we're going to go with. A is 10 and B is 24. Okay, so then A squared plus B squared equals C squared tells me that we're going to do 10 squared plus 24 squared and see if it equals 26 squared. All right. Well, we all know 10 squared, but 24 squared is one we typically don't. So 100 plus 24 squared is 576. And then 26 squared is 676. So then we add these together. 100 plus 576 is 676 is equal to 676. So this makes a true statement. So what do we think? Right triangle, yes or no? Exactly. It does make a right triangle this time. So this would be our answer. This one is yes, and this one is no. Okay, so those are really the two kinds of different problems you're going to see here. I'm going to have you guys try one real quick, and then we'll move along. This time your sides will be 42, 17, and 30. And we're wondering, is it a right triangle? So take a moment, decide if that makes a right triangle using the Pythagorean converse, and then when you think you've got it, type what you think in the chat, yes or no. If you chose 42 as your C value, you're on the right track. The other two can be either way. It could be A is 17 and B is 30, or the other way around. When you think you've got it figured out, make sure you type yes or no, whichever one you've determined, into the chat. All right, looks like so far we're getting mostly no's. All no's, actually. Lots of no's. Everybody seems to think it is no. Safety in numbers, right? You guys are correct. It is not a right triangle. So if you chose A to be 17 and B to be 30, you'd get 17 squared plus 30 squared, checking to see if it's equal to 42 squared. And 17 squared is 289. 30 squared is 900. 42 squared is 1,764. But 900 plus 289 only gives us 1,189. So this one would be a no. Okay. So that's really all we've got today. We have the Pythagorean theorem, using it to solve for missing sides. That's going to be a really big, important one as we go throughout the next couple of weeks, working with right triangles. And then also the converse, being able to determine if something is going to make a right triangle or not. So on a scale of 1 to 5, 1 being I'm completely lost, 5 and could use a lot of extra help or more examples, and 5 being this is super easy. What are we feeling? Right. Like mostly 3s, 4s, 5s. Awesome. Feel free to respond if you haven't yet. So here's what we're going to do. I'm going to post the homework assignment, and then if you would like more help or more examples, please stick around. We can do as many examples as you like. Oh, and then we have HSBP. So we'll get to that in just a moment as well. I'm going to post it. You'll be able to work on your own. And then we'll also talk about HSBP stuff before we get out of here. So let me find the assignment real quick. Today's assignment is going to be IXL. Because IXL has a lot of good right triangle stuff. Okay, so today's assignment for this class, we have one about the Pythagorean theorem and one about the converse. The first one about the Pythagorean theorem is not geometry Q1, it's 8th grade R3. Because 8th grade R3 has just the basic triangle stuff, and geometry Q1 had a bunch of like word problem stuff, which we'll get to at some point, but not right away. So this one will ask you like, what's the length of the hypotenuse? You want to use a squared plus b squared equals c squared to find it. Eventually, they will ask you questions where you get decimal answers, and you'll want to round those to the nearest tenth. Then the other section, the converse one, they'll give you 3 side lengths, and they'll ask you, is it a right triangle? And so you'll do what we just did, where you take the biggest one, 20 in this case, and make that c. And then use a squared plus b squared equals c squared and see if that makes a true statement. If it does, it's a right triangle. If it doesn't, then it's not. Okay. Then we're going to talk about HSBP real quick. So I'll stop recording.